So we have explored graphing the sine. You should have taken your 8-1A notes. You should have turned in those 8-1 stations from yesterday. So that was really exploring the sine, because once you get used to that, the cosine is very much related to it. So let's talk about what we should see for a cosine. Now, before they do that, I want to show you just this quick little video on YouTube. Now, this video is really cool because it kind of shows you, as you loop around the unit circle, what's happening. So let's just do a quick little. So as we go to the unit circle, our height starts at 1, or I'm sorry, our length starts at 1. That blue length starts at 1, and then it comes back toward the center. Now it's at a length of 0, and then it goes back to 1. So if we look, let's do it one more time. As we start on the unit circle, the cosine is our x value. It's going to start at 1. Now it's getting shorter, it's getting shorter, it's getting shorter. Now at pi over 2, it's at 0. Now it's coming back to a length of -1 this time. Now the length's getting shorter, it's getting closer to 0, it's getting closer to 0, and now when we get to 0 degrees, it's back to a height of 1. So that is how the unit circle stretches out and becomes the wave graph that we see. So keeping that in mind, remember on the unit circle, we are going to be focusing on the x values. So let's highlight the x values here. The cosine are the x values, so it is the length of the spot that we're at on the unit circle. So we're only going to focus on those x values. Now, if we know the 5 quadrantals, really that's the main ones we need, because we know the shape, or we should know that the shape is a wave. So when I go to graph a sine or a cosine, I'm going to give you the 5 quadrantals: 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those are my go-to 5. So I always do 5, but I have to keep in mind that it is a wave that is repeated far to the left and far to the right. And so there's going to be sometimes, like on your homework, I might say, hey, graph it out, what's called 2 periods of the graph, 2 sets of the wave instead of just 1. So sometimes I'll say fill up the graph paper. So continue the wave and just the pattern, go up and down, then up and down to fill up the graph paper. So what do we know? Well, at 0, we are at a length of 1, because that's our x value. The cosine of pi over 2 is 0. Now we're at -1. At 3 pi over 2, we're down at 0, -1, so our x value is 0. And then we are back up at 1 again. So the difference between the way that I kind of memorize the difference, the cosine of 0 is 1, so it starts at 1, but the sine of 0 is 0. It starts at 0 and comes up. The cosine starts at 1 and goes down. So let's put those points on. So let's kind of make this 1, and we'll make that -1. So the cosine of 0 starts at 1, Mrs. Hott, like you said one time. It sure didn't do. At pi over 4, it is 0.7. At pi over 2, the cosine is 0. So that is half of your bump. So that I see more of the bump for a cosine, sometimes I will just do the other half going the opposite direction. Even though it's not on my graph paper, it kind of helps clarify where that bump is for a cosine. Now, the cosine is what's called an even function. It is symmetric about the x-axis, or the y-axis. You can fold it over the y-axis very easily, and it is a perfect mirror image on both sides. The sine is not like that. It's an odd function. It has origin symmetry. It goes through the origin. So if you know that sine starts at the origin and cosine didn't, and thank you for your little faces there, that's helpful. Now, let's keep going. I know that the cosine of pi is -1. There's a little 0.7 right here, -0.7, and a -0.7. And then the cosine at 270 or 3 pi over 2 is back to 0 again. So there is the bottom bump. And you don't see the rest of the full little circle or little loop on the other side. This is 1. This is at 0.7. And if we had more graph paper, you know, we could finish that over there. So this does keep going. That wave continues forever and ever. So let's fill out our graph paper following the wave. So it's going to go down again, back to 0. Here's a bottom bump, the bottom part of our wave. Up again, back up to 1. Now, what's interesting about this is everything about this wave is symmetric. The distances are always going to be the same distance. So what do I mean? This distance between zeros, look, always the same. This distance between the top bumps, always the same. This distance between the bottom peaks, always the same. This distance, you know, in those parts of the symmetry, always the same. So the waves have a consistency about them. If your wave is skinnier in one part and fatter in another part, your wave is wrong. It is not a correct cosine or sine wave. So once you have one piece of it, make sure that you are graphing it correctly as you go through the process, okay? So that is what our cosine looks like versus our sine. So remember that our sine starts at 0 and goes up. So our sine graph starts at 0, goes up, then comes down. Our cosine doesn't do that. Our cosine starts at 1, then comes down, finishes a bump. So you always get this kind of weird cup feeling, like I don't know, a strange cup for a cosine. And so what I'll do to try to finish part of the wave is I'll kind of finish it over here so that I can really see where my bumps are at. So, you know, again, the symmetry of this makes it so if you don't see what you want, feel free to continue your graph to the left or to the right, because your graph continues to the left and to the right. Okay. Any questions about 8.1b so far? Okay. So we call the symmetry of a cosine function, this is an even function. It has y-axis symmetry. Algebraically, what does that mean? Well, the cosine of negative x is the same as the cosine of x. The cosine of negative x is the same as the cosine of x, because it just would flip it across the y-axis. And so if we flipped this graph right here across the y-axis, it would just line up upon itself perfectly evenly. So a cosine function is even, a sine function is odd. Now, there are going to be times we start in trig, we start with the unit circle, we go to the graphing, and then we start really relying upon the algebra of things. So we start doing algebra with this stuff. When we do algebra with this stuff, you're going to have to know that fact. It's just going to be a fact you're going to have to memorize. Just like we memorize the unit circle, there are going to be a list of facts that we're going to add to and learn more and more about how these relationships work. Okay, so that's a little bit about the symmetry. Some general things. Now, remember when we were doing the stations, we had some variables, A, B, C, and D. I did change it to a little minus C here. I think that clarifies a little bit more when it comes to some things that we do later on, but I'll show you one way or another. Okay, so yesterday when we were doing the stations, you might recall that A was related to our amplitude. The amplitude is really about the height of the wave. It stretched them up and down. It could have possibly, if it were negative, flipped it over. Okay. Remember, if it was fractional, it squished it because it made the height maybe only half or a quarter or a third or something. But if it was 2 or 3 or 4, it's going to stretch that wave. So all it does, if there's a 2 in front of our cosine or sine, it's going to stretch the height or change the height of the wave. Now, our height of our wave is normally 1 and negative, between 1 and negative 1. So if the amplitude is 2, it's going to be between 2 and negative 2. Okay. Next, how do you find the length of a wave? Well, the length of the wave is just the period of the wave. We're going to have to know that language. And all you're going to do is you're going to take this bx term, you're going to take it out, you're going to set it equal to how long the wave normally lasts. So let's think we have nice calm waters on the ocean. If everything is right with the world, the ocean wave, the sine wave, the cosine wave normally lasts 2 pi. Okay. Now let's say we churn up the ocean, there's a big storm. Now we might change that period. That's what the B does. It makes the waves more violent. It might make the waves even slow down somehow. So if you set the BX part equal to the 2 pi, what it normally is, it'll tell you what it becomes. So that's an easy algebraic move to find out what it becomes. If the B is a number like 4, it would be 2 pi divided by 4. The waves would become a little more violent. They would squish together, okay? If the B was like a half, it's going to slow those waves down. It's a super calm day, no wind, no nothing, not your normal conditions, okay? Next, we need to know the word phase shift. We talked about that a little bit yesterday. That is basically the C does the main shifting left and right, but the B will have an impact on it. So I just say, oh, I'll take that total parenthesis, set it equal to 0. Where did it shift? If you have a minus C in there, you're going to see we learned back in the first semester, if we subtract, it's going to move left. If that becomes a plus because the C, 2 negatives make a positive, it's going to move to the right. And, or I'm sorry, yeah. So if you have a minus C, when you see it, it's going to move to the right. If you have a plus C, when you look at it, it's going to move to the left. So that tells us our left or right movement, and that's what we're going to be calling for this stuff, phase shift. Last semester, we just said, hey, did it move left or right? Now we actually have a word for it. And then finally, anything you add or subtract on the outside does exactly what it always does. We're going to talk about moving what's called the midline, that vertical shift, and that's just where's the center of your wave? Okay, so again, we're in the ocean. There's a storm. The waves now are higher than they once were. That's what the D's value does. It takes and it moves those waves a little higher than normal. So we'll find that center line so we can really see where the waves are traveling. And so, so in this example, we're going to find the amplitude, the period, the phase shift, and the vertical shift or midline for this equation. So we've got this equation that's been totally mixed up. So let's figure out how we find each. Okay, so the first thing I want to do is the amplitude. So the amplitude is really just the A value of -3, but we can even think of it in kind of 2 parts. The absolute value of A tells us the height of the wave. So the height of our, from the middle of our wave up is 3, from the middle of our wave down is 3. So the amplitude of our wave is 3, okay? The actual negative part, the fact that it's negative, means that our wave is flipped. So if it's negative, it does 2 things. It changes the height of our wave and it flips the wave. So this one has 2 things occurring. So our cosine wave wouldn't start at the top and then go down. It would start at the bottom and come up, okay? Next, let's do period. You're going to set this term, that x term, equal to 2 pi. Now, if it is nothing that on the x, then the wave is just 2 pi. So the waves aren't violently crashing or slowing down. They're the same wave that they should be. And so that is our period. So our period hasn't changed. Okay. Next, we're going to do the phase shift. So you're going to take the whole parenthesis, no matter what it is, and you always set it equal to 0. That's where we're going to start. That's our starting place. Now, normally, we should start at 0. You know what I mean? It makes sense, right? We've started at 0 in our parent functions. But this tells us we have a new starting place. And you just add a pi to both sides. In this case, our starting place is at pi. So this graph does not start at 0. The wave starts at pi. And then finally, we have the vertical shift, or the midline. Now, the vertical shift or the midline is just this number here. Let's write y equals d. And that would be y equals 2. So it has shifted up 2. Okay. Now, I don't know if we actually graph it. No. Okay. So now, what I'm going to do is I'm going to pull up Desmos. We're going to look at the original. We're going to look at the new one, and we're going to compare the two. Okay? At least that's my goal. So first, let me just do it in phases. Okay. So y equals cosine of x is our original. Okay, so see how it's an even function. It has y-axis symmetry. It starts up at 1, goes down to 0, down to -1, up to 0. Okay, it's doing what it should do. Okay. Now, let's put a -3 in front. So let's actually, I'm going to put in the sliders. I'm going to try. Okay. So we're going to add the sliders. And this is something you can practice with. Now, you won't be able to use a calculator when you like take a quiz or something over graphing, but it's a good thing to play with when you're actually doing it. We know our A value is -3. Let's put that in there. So what do we know? An A value of -3 is going to flip over the curve, and it is going to, here, I got to make some of these values. That needs to be 1. Oop. C would need to be 0. I'm trying to get it so it's the original for you. Oop. And then I can see why you guys were. Can you? Thank you. I love when you guys show me stuff I had no clue. Okay. And then, oh, did I do something weird? Probably. And then the D value, that has to be 0. Okay. Okay. So all that the negative did, now look at the red curve versus the blue curve. The -3 in front flipped it upside down, and then it made the waves three times the height. Instead of at a height of 1, it's at a height of 3. Okay. Now, the B value is still 1. There's nothing in front of the X. Remember, our period is still 2 pi. That's good. Our phase shift, we should move to the right. So let's make that a minus pi. I totally messed this up. Wait, what did we say that B was? 1. Okay. And then our C value is now going to be a pi. Okay. And So it should have moved to the right of pi, but let's see. Let's make sure my c, yeah, so that's good. And then we just need the plus d, which was 2. Yeah, 2. Okay. So I'm also going to put in the actual midline y equals 2, not 23. Okay. So now let me blow this up so you can see it a little bit. Okay. So our original was in red. Okay, that's the cosine graph. Our new graph is in blue. The middle, see the middle of our wave is at 2 now? Do you see the height of our waves are up 3, down 3 from the center? So if you count it, up 3 and down 3 from that center line. What the pi did is it made the flip. If you flip and add or subtract a pi, it's kind of going to get you back to where you started. So anyway, that's what our graph would look like for that one. Okay, so now I want to practice actually doing a graph with you. So we've got 2 graphs I want to do together in class. So you can kind of get to the point where you can graph these hopefully. Okay, so remember the amplitude is our A value. If you don't see our A value, it's just going to be a 1. That tells me that the height of my wave is 1. The period is going to be this thing here set equal to 2 pi. So it's just x equals 2 pi. So the period hasn't changed. So you just set bx equal to 2 pi. In this case, x is 2 pi. The phase shift, we're going to set the parentheses equal to 0. So x plus pi over 2 equals 0 when x equals negative pi over 2. So that's negative pi over 2. Now, what does that tell us? That tells us that it is moving the entire graph to the left of pi over 2. Okay. That is also our starting value, which is going to be helpful in a little bit. Our vertical shift, or our midline, is at y equals negative 1. Okay, so now we've kind of pulled out the pieces, but what the heck do you do with the pieces once you have them? So that's what I want to show you next. Okay, so let's just do our parent function here. I just need the parent values, and then I'll show you what to do with them, okay? So a cosine, our 5 x's are always going to be, for this purpose, 0, pi over 2 pi, 3 pi over 2, and 2 pi. The 5 quadrantals starting at 0 and ending at 2 pi. So just count by pi over 2's. Remember that the cosine starts at 1 and should come back again to that very value. It goes 1, 0, negative 1, 0, 1. That is a pattern you just want to know. The cosine goes 1, 0, negative 1, 0, 1. As we loop around the unit circle, starting at 0, ending back at 2 pi, it goes 1, 0, negative 1, 0, 1. Okay, remember this is the cosine. Now, let's talk about what has changed. Okay. On the inside of the function, it is always going to affect our x values. So this right here is going to affect our x values. We already know that our starting value is negative pi over 2. Let's put that down. We already did that math. That is where the parentheses equals 0. The next thing, let's find our ending value. Where does our parentheses equal our ending value that normally would be at 2 pi? Now 2 pi, here's where your love of fractions is going to come into play. I know how much you guys love fractions. 2 pi's, think 2 pizza pies, is 4 halves. So 4 halves minus 1 half is 3 halves. Okay. And I know it's not in order, but the next one I'm going to do is, well, where's the middle of those two? So where does that, you can go in order, it doesn't matter. But where will that equal that middle value of pi? Well, if I have a whole piece of pie and I take off a half a pizza pie, I am going to have a half of a pizza pie. And so that's at pi over 2. And then we're just, because the measurements are always equally spaced, what's halfway between negative pi over 2 and positive pi over 2? Yeah, so you can just then, that's why I kind of do that, because then I can just cut them in half. What's halfway between 90 and 270? What's halfway between 90 and 270? 180. So that's pi. Now, you can do the trick, set the parenthesis equal to each 5 of those originals. It'll work every time, but I don't. I usually do first, last, middle, and then see if I can see the pattern, because everything is equally spaced. Always, 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 or it is not a correct sine or cosine curve. Okay, now let's talk about the y values. Anything on the outside of the function only affects the y value. So the only thing that's going to affect those y values are the things on the outside of the function, just like we learned in transformations from before. So this function has gone down 1. The midline is, the middle of it is now at negative 1. So all we got to do is take those y values and take off 1. So every single one of those y values, if we take off 1, now you don't have to write those down. You could just take off 1 from each one of them in your head. 1 minus 1 is 0. 0 minus 1 is negative 1. Negative 1 minus 1 is negative 2. 0 minus 1 is negative 1. 1 minus 1 is 0. For a cosine curve, outer 2 should match. Inner 2 should match. This one will always be different. Let me say that again. For a cosine curve, outer 2 will match. Inner 2 will match. The middle one will always be different. Patterns are helpful to my brain. I don't know if they are to yours. Okay. Now, how do we graph it on the graph paper? First thing I always do is look at my highest value was 0. My lowest value is negative 2. So I'm just going to make that negative 2. Just going to count by ones along the, for the y's. For the x's, I have to count by pi over 2's. I do have enough room that I can make this pi over 2 pi 3 pi over 2. You must fill up the graph paper each time. Fill up the graph paper each time. So this is negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. So I'm just counting by quadrantals. Okay. The first thing you always put on the graph paper is your midline. Always, because it's going to help you see where how your wave is moving. So we had a midline at y equals negative 1. Put it on there. Don't start anywhere else. For every single graph we're going to be doing, you always put on the midline first. Because that's going to be tell you, I'm going up 1 from there, down 1 from there, up 1 from there, down 1 from there. And my numbers don't do that. I'm wrong. So it's going to be your guide. That is where the middle of your wave is lying. Okay? Okay, now let's put our numbers on. At negative pi over 2, we are at 0. At negative pi over 2, we are at 0. At 0, that is not 0, is it? Okay. At negative pi over 2, we are at 0. At 0, we are at negative 1. At pi over 2, we are at negative 2. Now remember, for a cosine curve, you get a half a bump. You don't get a full bump. Now you could go the other way, equally spaced, because everything on a sine and cosine curve is equally spaced. You could finish that bump to the left if you want. I do. It makes my brain a little happier. At pi, we are at -1, back on the midline. Make the bottom bump. At 3 pi over 2, I'm at 0. I always get a half a bump. I get a half a bump down below, an other half a bump. Let's finish that one out. Equally spaced. Now, I am going to always fill up my graph paper as you are, because I know you will. Yes, you will. You will. If I could send out messages to your brains. Okay, so let's go down, equally spaced, 2 over and down, 2 over and on the midline, and let's make a lower bump. If they become wonky because you haven't counted the correct number of spacing, you are doing it wrong. These are perfectly oscillating waves that repeat endlessly and perfectly from left to right. They do not squish together sometimes and come back apart. For that to happen, you have to have a lot of other things happening, and you have to have like cosine of x plus x squared plus, you have to have lots of other things. So they are a perfectly symmetrical wave, or, oscillating wave about your midline. So look at for where our midline is. From where our midline is, it's going up a bump, down a bump, up a bump. Everything is perfectly spaced. These are perfectly spaced. These are perfectly spaced. There should be a symmetry, a wave about it. It should be perfect. Okay. Do we have any questions about example 5? Okay, now let's look at example 6. We're going to do one more, and then you're going to practice yourself. The amplitude here is actually the absolute value of -1 or just 1. The height, it's a length or a measurement. You don't use the negative, but the negative means that our values are going to flip upside down. So our cosine usually starts high, goes to the middle, and down low. It's going to do the exact opposite. It's going to start low, go to the middle, and go up. So it's going to go low, middle, up instead of high, middle, down. The period, we're going to set this 2x equal to 2 pi. You always set the x term equal to 2 pi and solve for x. If we divide by 2, we get that the period is now pi. This wave has become more violent. It's been smushed together toward the x-axis. It has been compressed. So now we finish a wave in a pi instead of in a 2 pi or whatever the other things that we've done. Well, they've been 2 pi so far. The phase shift, we're going to set 2x minus pi equal to 0. You always set that parenthesis equal to 0 for our phase shift, and you solve for x. So you're going to get 2x equals pi, x equals pi over 2. That is our start. Let's put it on the page. The phase shift is always our starting value. Put it on the page. Put it on your XY chart. Okay. Let's find our vertical shift. Our vertical shift is just this number here. Let's write it as a midline. It's going up 1. So our center of our wave is now at +1. So this wave has been flipped. This wave has been smushed. This wave has been moved to the right of pi over 2, and this wave has moved up 1. But it's still a cosine wave that has just been altered. Now, let's go ahead and put our parent cosine on here. Now, I have this down on the homework. I have 2 XY charts. I want you to always write the parent sine or cosine for a while until you get those patterns pulled off the unit circle. And so it goes, let's do our x's. We're just going to do quadrantals, 0, pi over 2 pi, 3 pi over 2 and 2 pi, one loop around our unit circle with the 90-degree angles. The cosine starts at 1, goes to 0, goes down to -1, back up to 0, and finally at 1. These two match at 1, these two match at 0. This was always the lowest, well, for the parent. Okay. Now we need to do the new function. We have the starting value and not much else. So let's find the ending value. Now we're just going to set the parenthesis equal to 2 pi. It starts at 0, it ends at 2 pi. Where is this function 0? Where is this function 2 pi? Well, the ending y value, we're just going to subtract, no, we're going to add a pi to both sides. We get 2x equals 3 pi's. Divide by 2, x is 3 pi over 2. So this is 3 pi over 2. What's between 1 pi over 2 and 3 pi over 2? What's 2 pi over 2 or pi? So we get this middle one. What's between pi over 2 and pi? Think about your unit circle. And it's not always a bad idea to have the unit circle. I told you to take a picture in your camera roll. But what's between, exactly between, let's go 90 and, yeah, 3 pi over 3/4. That 45s. What is the pi over 4 that's exactly between 180 and 270, between pi and 3 pi over 2? What's the pi over 4 exactly between pi and 3 pi over 2? That would be 5 pi over 4. Now, if you didn't see that, you could set the parenthesis equal to 0. You'll get that. The parenthesis equal to pi over 2. You'll get that. The parenthesis equal to pi. You'll get that. And so on and so on and so on. So you can set the parenthesis and do it 5 times. But if you use logic and fractions, sometimes fractions are our friends, you can get the x values we see there. Okay, now let's find the new y values. There are two things that are affecting the y values. It's the negative of the old y plus 1. Here's where the old y is sitting. So it is the opposite of the old y plus 1. Algebraically, the old y is going to pop out right here when you plug these in, because that's what we were trying to get it to become. So it's just the opposite of the old y plus 1. What's on the outside of the function? Anything on the outside of the function only affects the y values. So it's just the opposite of the old plus 1. Okay, so let's take our old y, and we're going to do the opposite of the old y plus 1. So the opposite of 1 plus 1 is 0. The opposite of 0 plus 1 is 1. The opposite of negative 1 plus 1 becomes 1 plus 1, or 2. The opposite of 0 plus 1 we already found was 1. The opposite of negative 1 plus 1, or the opposite of 1 plus 1 is 0. For the cosine to be correct, these two should match. These two should match. That one will be different. Okay. So now we have our new values. The first thing we always put on a graph paper is the midline. So our midline is y equals 1. Let's just call this 1. We have to count by pi over 4s this time. So just count 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4s, and I think we'll be okay. So let's call this pi. So that's 1 pi over 4, 2 pi over 4s, 3 pi over 4s. So 1, 2, 3, 4, that would be 2 pi. 1, 2, 3, 4, negative pi. 1, 2, 3, 4, negative 2 pi. Just count jumps, so we're counting by force. So count your jumps from the center. Jump 1, 2, 3, 4. I'm counting by force. Count the jumps. 1, 2, 3, 4 jumps. I'm counting by force. If your fraction ends up being 8s, count 8 jumps to make a pi. Okay. Okay, so our first point is pi over 2, I'm at 0. Pi over 2, I am at 0. And then 3/4, I am at 1. So 3/4, I'm on the midline. See how I got a half a bump? You always get a half a bump with a cosine. I always like graphing sines a little better because you get a full bump really fast, and so it just feels more like it's doing what you're supposed to do, okay? We can finish the other side over here if we want. Then at pi, we are at 2. And then at 5/4, we are back on the midline. We have finished a bump. That is an ugly bump. And then at 3/2, which is 1.5, which is right between pi and 2 pi, I am back at 0. So that's still half a bump. So why not finish it to the other side, exactly the same distance away? Now, if this was a quiz or a test and you were turning in this particular graph, I would mark a point off because you haven't finished it. The cosine and sine graph does not end there. It goes on endlessly to the left and to the right. So finish out as much as the graph paper allows. So counting exactly the same spacing, one jump over is up, then down. I have an upper bump. To the left, up, then down, I have an upper bump. Down, then up, I have a lower bump. Up, then down, I have an upper bump. Down, then up, I have an upper bump, or lower bump. And I keep doing that until I fill up my graph paper. My wave should be consistently spaced, or I did it wrong. Our wave should be consistently placed. I am going to check how you decided to number your number line. Break up the pi's along your x-axis, your y-axis, space it however you want. Usually my y-axis, I'm spacing by ones. My x-axis, I'm usually counting by pi over 4s or pi over 2s is pretty common. There's only going to be a few you'll probably have to go down to pi over 8s or something like that. So tomorrow in class, you will have all class time to be working on the 8-1A and the 8-1B. If you don't know your unit circle, you are not going to do this well. Please make sure you know that unit circle, that the sine values go 0, 1, 0, -1, 0, and the cosine values go 1, 0, -1, 0, 1. And we'll probably have a memory quiz on that. We'll probably have some things where we'll have to graph some soon. Okay, so your homework is the 4 problems you see below. Each time you're telling me the amplitude, each time I want you to give me the parent also. Please give me the parent. 0 up to pi, to 2 pi, and you know how the cosine goes. It goes 1, 0, -1, 0, 1. Okay, so each time I want you to write it not because anything more than it's going to start clicking in your brain. The more you write it down, the repetition, unfortunately, isn't a fun thing, but it is a necessary thing to memorize some stuff. Okay, so expect to have time in class tomorrow to be working on that. Don't forget you have a February Achieve due tomorrow. You're not turning in the Chapter 8 notes until the end of the chapter. But if you're doing it on paper or something untraditional, make sure you're taking a picture so you don't lose something. So there you go. There's how we graph a cosine.